Now we'll look at some extra tips that can help you when you're solving trig equations. Now, if you've got reciprocal ratios in there, that means cosec, sec or cot in your equation, look to change it to sine, cos and tan as soon as you can. Now, it's possible you might be able to take the reciprocal of both sides of the entire equation by basically just flipping it upside down. So, for example, if you see something like cot of theta equals 2, alright, then if you want to convert that to tan of theta, you know that tan and cot are reciprocals of each other. They're basically like a fraction that's been flipped up the other way. Well, all you need to do is take the reciprocal of the other side. Now, 2 doesn't look like a fraction, but it's really 2 over 1. So when you flip the 2 upside down, you'll get a half. And straight away, you're well on the way to solving your equation with a ratio that you're nice and familiar with. Now, if you didn't know this trick, you can get a little bit more caught up. You'll still get there, but it just might take longer to say, all right, cot, that's the same as 1 over tan. And then on the next line, you might say, all right, now we've got to multiply both sides by tan theta, and then divide both sides by 2. You're still going to get the same thing, but it's just going to take you a little bit longer. So do things that are quick so you can spend more time on the hard stuff. Tip number 2, if you're solving for boundary angles, and that's angles that are multiples of 90 degrees, use the trig graphs to make sense of your answer. Now, the reason we want to do that is because those angles are not actually in any one quadrant. So when you're trying to work out which quadrant they're in, and you say, hey, I've got a negative, so it must be here or there, it can mess you up a little bit unless you use this method. Now, to solve something like this, we've got a domain where x is between 0 and 720 degrees, and we know that cos of x is negative 1. Now, recalling the graph of y equals cos of x, remember it starts up here on 1, and it toggles between 1 and minus 1, moving along like this. Now, how long does it take to do one full revolution or one full cycle? It takes 360 degrees. So on our graph, this would be 360. So if we're going to graph this, we need to go a bit further until we've come all the way, 1 full and then 2 full revolutions. So 720 will be up here. All right, now if we want to find when cos of x, because this is the graph of y equals cos of x, if we want to find when cos of x equals minus 1, then if y equals cos of x, then we really want to say when is y equal to minus 1. Okay, so we can actually draw a line along here where y equals minus 1 and see where it connects up with our graph and find that it's here and here. Now what are those points? That's 180 degrees, and this is 540 degrees. So we can solve this one really quite neatly and easily just by drawing a graph, and this is a perfectly acceptable way of showing you're working. If you put this in your HSC exam, an examiner will think you know exactly what you're doing. X must be 180 degrees or 540 degrees. And you can be really sure there that it actually only touches that point twice, so you can be convinced that you've got all of the solutions. Now, if you're a bit unclear about why this makes sense, perhaps it might be helpful to cast your mind back to when we were solving quadratic functions. If we had something like this, now if I say x squared equals 9, I'm giving you an easy one because you know the answer to that is that x could be 3 or it could be minus 3. But just have a look at this as a little strategy. If I was to graph y equals x squared, and I was to graph y equals 9, because notice there's no y in either of these sides of the equation, then I know now that y equals x squared is a parabola, looks something like this. And so I've graphed y equals x squared, and I can also graph y equals 9. And the point where those two graphs meet up, those will be the x values that you find there of 3 and negative 3 will be the answers to the original equation that you were given. So you can use the two-dimensional shape of graphs to answer questions that don't appear to actually have 2 dimensions in them. And the same thing's going on over here. There's no y in this question. There's only x. And yet we've used our understanding of a curve to answer it. How have we done that? Well, we basically graphed y equals cos of x. And then we graphed y equals minus 1, and we had a look at where the two lined up. We basically solved a simultaneous equation and had a look at how many solutions there were and read off the graph what the x values of those solutions were. Tip number 3, if necessary, you need to adjust the domain that you've been given to suit the equation. Now the reason that you do this is when you've been asked to find the trigonometric ratio of something that's not just theta or x, it's maybe 2x or maybe it's x plus 100 or something, and it'll generally be in brackets. Now in this question you'll notice that we've been given a domain, but the domain involves x, whereas the trig ratio involves 2x. Now there's a couple of ways of dealing with this. I'll show you 2 methods and you can pick your favourite. What I like to do is say, if I'm dealing with 2x, then, and I only know what the domain is for x, I'm going to write a new domain now for 2x. Now, an inequality basically has 3 parts to it. You can treat it like an equation. And if I've doubled the x here to make 2x, I have to double the 0, still 0, and double the 360 to get 720. So that means the angle that I'm looking for here, which we'll call 2x for now, it's got a much bigger scope now. It can be between 0 and 720. So I need to look further. I almost need to go around the quadrant circle twice to get the full 8 quadrants that are in this question now. Okay, so now I need to think about which quadrants we're in. So if sine is negative, think through your all stations to central. Sine is positive in the first and second quadrants and negative in third and fourth. So I need answers in the third and the fourth quadrant. But clearly I'm looking further than 4 quadrants. I'm looking all the way up into the 5th, 6th, 7th and 8th quadrant. Now what does that mean? Well, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th and 8th. I actually want the 7th and the 8th quadrant as well. So I'm actually looking for 4 answers because I'm looking over such a big domain. Alright, so how do we solve it now? Well, let's think. Sine of something is half. Remember, we don't put the negative half in. We just think sine of something, this can be our something, is half. Now I know that the sine of 30 degrees is half, but if I didn't know that, I'd just type inverse sine 30 degrees into, inverse sine half into my calculator and it would spit out 30 degrees. So that's the related acute angle. Now what do I do with my 30 degrees? If you want, you can jot it down. Related acute angle is 30 degrees. Now we need to put it into all of these quadrants. Okay, so in the third quadrant, we're down here, we have 180 plus the angle. So we can put our solution here as 2x equals, now why am I putting 2x? Because that's the angle we're trying to find first. We're trying to solve for 2x first, then we'll solve for x later. Alright, 2x could be 180 plus 30, that's 210. 2x could also be in the fourth quadrant. And if my related angle is 30 degrees, I've got to do 360 minus 30. That'll give me 330. Could also be up here in the 7th and the 8th quadrants. Now the quick trick to working out those is just to take these 2 answers and then add 360 degrees to them, because you've basically gone round to there, then you've gone all the way around again. So adding 360 to this gives me 570 degrees. And adding 360 to this gives me 690 degrees. Alright, now we've solved what 2x could possibly be. It's quite simple to just say, well, what's x then? We need to just halve it. We've halved this side, so we need to halve everything on this side. So we've got 105 degrees, 115 degrees, we've got 250 plus 35, we've got 285 degrees, and here we've got 345 degrees. Now we're finished, but when you're finished, make sure you always just check, are all of my answers actually inside the domain that I was given? X had to be in here, and sure enough, they're all fitting inside. Now, these questions are tricky if you don't look for those extra answers. So really the key is adjusting the domain in the beginning. Now I said I'd show you 2 methods. The other method that people sometimes use is literally just to say, I'm going to rewrite this. I'm going to say let 2x equal something. Let's use another symbol like mu. Now if 2x equals mu, you can rewrite this whole problem here. Let's use a different colour. And just say sine of mu equals minus a half. Then you can go ahead and solve for mu, all right? Now over here you'd do the same thing. You'd say if x has to be this, 2x has to be that, and then you could actually say, all right, so mu has to be between 720 and 0 because mu is 2x. So you'd write that third line. Then you go ahead and solve for mu, and of course your line of working is going to be giving you exactly these 4 answers. Then you'll change it to 2x and then to x. Now if you like that method, feel free to go for it. It's explained in our textbook. I think it's a little bit clunky and a little bit of sort of rewriting the same thing, but if you're getting these wrong, maybe try and switch to this method. Another example that uses a compound angle here, we need to adjust the domain to suit the equation. So we know that x needs to be between 0 and 360, but we're not solving for x in the beginning, we're solving for x plus 100. So if we put x plus 100 in here, then what have we done to the x? Well, we've added 100. So we need to add 100 degrees to both of these to change the domain to suit our question. All right, now if you're going to do it this way, what you need to do is still think through the quadrants, and then you need to try and solve for x plus 100. So we are actually solving for x plus 100 first. Okay, so cos is positive here, that's our first clue. So thinking through the quadrants, we've got all stations to central, cos is positive here and here. So it means we must be in the first or the fourth quadrant for our x plus 100 degrees. Okay, so cos of something is root 3 on 2. This is a familiar one to me. It's one of the exact values that we should have learnt now. So I know that cos of 30 degrees is root 3 on 2. So that tells me that x plus 100 degrees must be either, well, 30 if it's in the first quadrant, or if it's in the fourth quadrant, then I need to do 360 minus 30 to get that. Okay, now am I between 100 and 460? No, I'm not. 30 degrees is not in the right place. Now, can I convert it? Because I still want 2 answers. Okay, how do I know I want 2 answers? Well, because my original domain is 4 quadrants in width. Okay, and even when it goes up by 100, it's still 4 quadrants in width. So the fact that this has moved up 100 means that I need to be looking up further. So how can I convert 30 degrees into something bigger? Well, think about what 30 degrees looks like. It's a ray that's here, all right? It's exactly the same ray as if I go around a full 360 plus another 30. It's exactly the same as 390. How do I know? Because 30 plus 360 is 390. So now I have these 2 answers. All right, they sit between the domain that I want for x plus 100, and they're both happy in there. So how do I find x then? Well, what have I done to this side? I've subtracted 100. So to this side I need to subtract 100. So that gives me 230 degrees and 290 degrees. Now again, many people will use the substitution method here. Let's use a different colour to say if x plus 100 degrees is there, then let's let x plus 100 equal, say, mu, and they'll write in here that mu must be between 460 and 100. Now, whether you call it mu or you call it x plus 100, you're still going to put that here. So people using that method would have written their mu in here. Then they would have probably had another line in between that said, therefore, x plus 100 equals, and written those same 2 numbers down, and then they'll halve it. It's an extra step, so some of you might not feel like it's strictly necessary, but you can see that it just keeps it nice and clear what you're finding the cos of. You don't need to do it as long as you make sure that what you're writing down here is actually x plus 100, not just x.